So in this problem, what we're having here is a matrix which has the order 2 by 2, and we're supposed to find the inverse of this matrix using elementary row transformation. So as you can see, we're having this matrix here. We're going to name that as matrix A. So we know that when you're having a matrix into an identity matrix is obviously going to be the matrix itself. Okay, so what's going to happen now is we're going to replace the A on the LHS with the A matrix and the I with the identity matrix. So remember that when you're doing the problem, what we have to do is we basically have to make the LHS into an identity matrix. When you make the LHS into your identity matrix, your RHS identity matrix is going to become into your inverse matrix. So basically what we are to do is we're going to make the LHS into 1, 0 and 0, 1. So we already have a 1 in the first position, as in the first element is already 1. So all you have to do now is you're going to try and make the third element into a 0. So to do that, what we're going to do is we're going to have R2 is equal to R2 minus 2 times R1. Okay, so that's basically because we have a 2 in the third position, so we're just going to make that into a 0. So when you minus it, we're going to have a 0. So now we already have a 1 in the fourth position. The fourth element is already 1. So what we're going to do is we're going to move on to your second element and try to make that 0. So what we're going to do is we're going to take R1 and we're going to say that R1 minus 3 times R2. So once you've done that, you're going to have 1, 0, 0, 1 on your LHS. And since you already have 1, 0 and 0, 1 on the LHS, obviously your RHS is going to be your inverse matrix. Remember to always apply the operations throughout for both the LHS and your RHS. Don't just apply it for LHS. So once you've done that, now you have your inverse matrix. So your inverse matrix is going to be 7 minus 3 in the first row and minus 2 and 1 in the second row. So that's going to be your answer.